The big shift this week is that we're getting much closer to seeing what LLMs are actually doing inside the decision loop, and, in one case, using that signal to improve performance without retraining. That matters because the final layer is not always the smartest place to decode from. Sometimes alignment and safety post-training tilt models away from their own best reasoning. At the same time, researchers are starting to extract causal explanations from model behavior instead of just post-hoc rationales, and to test whether those rationales reflect real decision structure at all. Let's explore the first paper. Deeper is not always better. Mitigating the alignment tax via confident layer decoding. The paper from Alibaba's Qwen team, with co-authors from Tsinghua University and Nanyang Technological University, argues that deeper transformer layers are not always the best decoding point in aligned LLMs. By analyzing Qwen 3-5 models, it identifies a recurring guess, refine, perturb pattern. Early layers guess, middle layers sharpen reasoning, and the final layers can perturb predictions toward generic or safety bias tokens. The proposed confident decoding method is training-free and drop-in. At each token step, it computes intermediate logits over a near-final window, then backtracks to the first local minimum in predictive entropy, which the authors call the entropy valley. On Qwen 3.5, 3.5b, A3b, the method selects a non-final layer for 11.5% of tokens, but only 2.47% of all generated tokens actually change their argmax, while end-to-end latency stays under 2% with 0 extra KV cache memory. Across dense and MOE models, it improves GPQA Diamond, HLE, Live Codebench v6, and OmniMath with especially large reasoning gains such as plus 6.5 on GPQA Diamond and plus 10.1 on Live Codebench v6 for Qwen 3 527b and plus 22.4 on the hardest OmniMath tier for GPT, OS 20b. The paper also shows the effect is stronger in instruction-tuned models than base models, supporting its claim that post-training alignment introduces an alignment tax that confident decoding can selectively bypass without sacrificing safety on Airbench 2024 or writing quality on Writing Bench. Let's explore the second paper, LLM explainability with counterfactual chains and causal graphs. This paper, from Technion and IBM Research, reframes LLM explainability as a concept-level causal discovery problem over the model's own inference process, not the external world. Using Gemini 2, Flash, Qwen 3, 1, 4b, and OpenAI's GPT, OSS 20b, it builds a 4-stage pipeline. Replace gold labels with LLM predictions, extract human interpretable discriminative concepts, generate counterfactual text chains with an MCMC-inspired acceptance test, and learn a causal graph with Sigma CG. The method is evaluated on 3 classification settings: Liberty disease diagnosis with 1,448 examples, IMDb sentiment analysis with 2,096 examples, and an LLM as a judge Reddit preference task with 395 examples. Across 1.0, fold cross-validation, graph-based parent sets consistently outperform alternative concept subsets. For example, on Gemini 2, Flash disease diagnosis, prediction accuracy rises from 0.61 for competing subsets to 0.67 for the learned causal parents, while concept node prediction reaches 0.54 versus 0.51. The MCMC augmentation uses 11 counterfactual steps per seed, up to 5 refinements per proposal, and a drift tolerance of 1 to 2 non-target concepts, and its KL divergence traces converge toward the perfect overlap bound with structural Hamming distance dropping to 0 for Gemini and Qwen on the synthetic and IMDb settings. The resulting graphs expose model-specific heuristics, shared clinical concepts on Liberty, but divergent, latent features on natural data, showing that faithful LLM explanations can be made both causal and interpretable at the concept level. Let's explore the third paper, Superficial Beliefs in LLM Decision-Making. Superficial Beliefs in LLM Decision-Making from Imperial College London asks whether models such as OpenAI's GPT, 5, Mini and GPT, 5, Nano, Qwen, 3, 1, 4b, and Ministral 314b merely rehearse explanations or instead exhibit a recoverable local decision structure. The authors build a synthetic binary choice benchmark with 4 graded attributes across drugs, policy, and software themes, plus 2 control themes, and a structurally different 6-attribute hospital cyber response setting. They fit a binomial logistic behavioral model to 400 training families and evaluate on 100 held-out families, comparing its recovered driver with 2 explicit elicitation methods, direct response and a score-based judge. Across the main benchmark, the behavioral model matches held-out choices 80.4% of the time, while the explicit direct report names the recovered driver only 61% of the time and the score-based judge 61.3% of the time. The same pattern survives perturbation and intervention. Score-based judge outputs are more reproducible than direct responses, yet they are not more faithful to the recovered decision driver. And in the control themes, irrelevant attributes are selected only 0.2%, 1.6% of the time. A targeted occlusion study on GPT, 5 mini non-thinking drugs, shows that higher ranked attributes induce larger choice and rationale flips, supporting the claim that these models behave as if guided by probabilistic attribute local priorities rather than fully articulated beliefs. That's a wrap on today's AI paper highlights. Thanks for watching.